Stack again. Stack, stack, stack. I need to solve like 80 medium problems. Oh my god, bro. 80 medium. Yeah, I think I can do it. I walk niggas down. Should I do some music while I do it? Yeah, I think music kind of like fucks my focus up. Even like the lo-fi beats fucks your focus up. So let's just raw dog it like back in the day. I still don't understand this. Still like what the fuck am I looking at? It's fresh eyes now. I think I can like kind of comprehend a little bit better. Let's see. So we're iterating over the string to find. Fuck! It's cold. It's cold. It's eager. She's loving my demeanor. Okay, let's do this. I can't. The mouse doesn't work. Can I do this? Oh shit! It's too much. You know, like too much distance. Yeah, this is like this helps for sure. Why does it not work? Bro, why? The mouse, it's on. Yeah, the mouse doesn't work sometimes. Oh, it's because I need to do this shit. Yo, I actually like man. Okay. I actually don't understand this till now. But I am gonna move on to the next one and I'm gonna come back to this one. I haven't submitted it, so where is my fucking mouse? Wow, it's so convenient. I think I can do it without this. So the way, let's Let's go here. Okay, fuck. Let's do this. I don't understand this, but let's just like give it a
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem, implement a stack using queues. I think this is a really good problem for beginners to kind of get familiar with stacks and queues and the relationship between both of them. So a stack is a LIFO data structure. Last in is the first value out. So basically, if we add a value here, and then we add a value here, and then we add a value here, right? We add values in this spot, but we also remove values from the same direction because the last value that we just added, 3, needs to be the first value that we remove. So we remove the 3. Then the next value that we want to remove is the next most recently added value, which is a 2. So we remove it. And these operations, adding, which is called pushing, and popping, which is removing, are both done in big O of one time and constant time. Now there's other operations like top and empty, but those are pretty trivial and really easy to code up, so we're not going to focus on those. And in this case, we are told to implement this data structure with a queue, and actually we're allowed to use 2 queues, and the follow-up is to use just a single queue, but I'm just going to start with the follow-up, which is using a single queue. I don't think it even makes sense to do this with 2 queues. Though the thing I will mention to you is don't get hung up on implementing these stack operations in big O of one time, because it's actually not even possible. We can push
session. What even is stack? You gotta ask yourself, what is stack? Stack and queues data. Okay, let's look at this.
Hey guys,
I know what
Greg
it is.
here.
What am I gonna learn new?
Thing that you put.
Yeah, no one cares. Let's just like look into like the monotonic would be increasing and decreasing stack. So let's do, is this an easy one? I want like only easies, bro. Don't give me hard questions, brother. If you give me hard questions, I'll quit. I'm gonna quit at the first side of like hard question. I'm done. Bro, why am I? Oh, the fuck. Why did I do that? Should be. Is it an easy one? I think it's a medium one.
Hey everyone.
Oh no, bro. Why doesn't this guy like color code it? You know what I mean? You could like easily color code this with like, if it's an easy question, it can be like blue. The text could be like the blue. You know, like Anthony Fantano kind of color codes all of his videos based on ratings. It should be like that.
Hey
I think.
everyone, welcome back, and let's
I would
write
do
some
that
more neat code
on
today. So
future
today
videos.
let's solve the problem next greater
Okay.
element 1. And I'm actually going to be doing both solutions for this problem. So over here you can see that there is a follow-up for this. So there's going to be kind of an n squared solution, and then the more efficient one, which is pretty much a big O of n, where n is going to be the size of the larger input array. But
so I'm going here. It's 496. 496. Fuck's sake. 496. This will be this one. Topics, brother. Is this okay? Topics, stack, monotonic stack. Yeah. Can you like not do this, please? It's annoying me. So let's look at the example. The greater number of each value num1 is follows 4. Okay, they're given 2 arrays, and the output is this thing. What even? Okay, what am I supposed to do? Generate a greater number. Let's read the question ourselves. The greater element of an element x is an array. Is the first greater element that is the right x of the same array. You're given 2 distinct integer arrays, nums1 and nums2. Okay, I can see it. Where nums1 is a subset of nums2, meaning this one is found in this one. Or is it the other way around? Yeah, okay. Okay, the first element, the first list of elements is found in the second list of elements. Cool. For each, okay, find the index of j such that nums of I is equal to nums of j, okay, and determine the greater element of, and there's no greater element, is -1. So I'm supposed to find the greater element and where it is found. If there's no greater element, the greater number of each value of nums1, 4 is underlined. Okay, there is no greater element, so the answer is -1 on this example. Okay, let's look at this.
Before we do that, let's actually understand what the problem is asking for. So first of all, the next greater element of some element in an array is defined as being the first greater element to the right of that element in the same array. So it's pretty intuitive, just like the name says. We're given two arrays, nums1 and nums2, where nums1 is actually a subset of the second array. And what the problem is asking for is a little bit tricky to understand. So if we were just given this array nums2 and we had to find the next greater element of every single value in this array, that's simple to understand, but what the problem is asking for is actually a little bit more complicated than that. So basically, since nums1 is a subset of nums2, we actually only want to find the next greater element of the values in this array that are also included in the first array. So we don't want to find the next greater element of every one of these. We only want to find the ones that are 4, 1, and 2. So 4, 1, and 2. You can see that they don't even show up in the same order, so that's going to be a little bit annoying. And so the output that we return is, of course, going to be the same size as nums1, and the order of the values is going to be the same. So if we want to know the next greater element of 4, well, we look at our second array. 4 is over here. What's the next greater element of it? 2 is not greater than 4, and there's no other elements here, so 4 doesn't have a next greater element. So the default value that we do in this case is going to be -1. So we just put a -1 in the output. The next value is 1. What's the next greater element of 1? Well, looking at the next value, 3 is greater than 1, so that is the next greater element of 1. 4 is also greater than 1, but 3 is closer to 1 on the right side, so we use 3 in the output. For 2, 2 doesn't have any elements to the right of it, so it doesn't have a next greater element. We can just put -1 there. So the brute force of this problem is not super crazy, but it's a little challenging for an easy problem. So one way to approach this problem is to kind of just find the next greater element for every single one of these, because we know if we do that, we'll pretty much have what we're looking for, and then we can create the output. But at the same time, we could also skip the values we don't need to. In this case, 3 is not in the first array, so we don't need to find the next greater element of 3. So what I'm actually going to do is convert the first array into a hash map, where we're going to be mapping every single value in that array to the index that it shows up in the same array. The reason we're going to be doing that is because, let's say, we are iterating through each value in
It's
n.
not
so
even
we
the
have
right
1.
problem.
So first we would want to know, does 1 equal...
The brute force.
This is going to take a stack to solve. And I'm just going to tell you straight off the bat that this is going to take a stack to solve. But it's not super intuitive to know that it's going to need a stack, especially if you never solved this type of problem before, if you've never heard of the monotonic stack technique. But I'll try to explain the intuition of why.
Monotonic stack. That's the intuition behind it. So I gotta ask myself, not this one. Is the monotonics? I mean, it is, yeah. Let that shit go, and let's look at this. Oh, no, not you, buddy.
I changed the example a little bit, though, because the original example doesn't really lead to the intuition of a stack, so that's why I changed the order of the values, at least, to this, because this will be a bit more interesting. So let's say we started at 2. We know 2 shows up in the first array, so we want to find the next greater element of 2. We look at the next value, 1. It's not greater than 2, so it's not the next greater element. Then we look at the next value, 3. It is greater than 2, so we found the next greater element of 2, and we can add it to the output. But hold on a second. If 3 is the next greater element of 2, shouldn't it also be the next greater element of 1? Well, that's only the case if 1 even shows up in the first array, which it does, but then that is the case. And that would be the case for any number of values. You know, suppose before the 3 and after the 1 we had a 0 over here. Then we'd say, well, 1 is not greater than 2, and 0 is also not greater than 2. But when we finally reach the 3, 3 is greater than all of them by definition, because all the values that came after 2 before 3, they were definitely not greater than 2. That means they must be less than 2, because all the values in the input array are unique. So that means when we find the answer for 2, we're also finding the answer for all the values in between. That's where the stack is going to come in, because we want to remember all of these values. In this case, of course, there's only 2 of them, but like I said, there could be a lot more. So how the solution is going to go is we're going to start at 2. It's in num1, so what we're going to do is add it to the stack. You're going to notice that this is going to be a one-pass solution. We're not going to have nested for loops. Next, we're going to look at the value 1. First of all, is it greater than any of the previous values that we need to find the next greater element for? Well, we're going to check that by taking a look at our stack. What's the top value on our stack? It's 2. So 1 is not greater than that, so we didn't find the next greater element of 2. But 1 does show up in n1, so we are going to add it to the stack, because this is another value we need to find the next greater element for. Okay, and then we look at 3, and we're going to compare it to the top value of our stack. Notice how the stack is always going to be in decreasing order. It has to be, because by definition, if we find a value like we just did now, we found a 3, and that's greater than the values here. So now what we're going to do is pop all of these values. What we're going to do is see 3 is greater than 1. We found the next greater element of 1. 1. So what we're going to do is find the index of 1. We're going to use the hash map that we talked about in the previous solution to do that. So we're going to say the next greater element of 1 is going to be 3.
Brother, this is too complicated. Monotonic stack. Explain the monotonic stack.
Given an array, find the next greater element and the previous greater element of element I. Let's see what this means by the next greater element. For example, for 5, the next
Monotonic
greater element
stack.
will be 9. For 3, the next greater element will be 9. For 2, the next greater element will also be 9. And for 9, there's no next greater element, and for 4, there's also no next greater element. But how do we achieve finding these in a single run through the array? To do this, we have to use the monotonic stack. Let's try an example to find the next greater element for each number in the array.
Bro, not explaining the question. Who do we even... Ah, my neck. Sometimes I just want to get like my neck cranked like the Hitman death thing. I just want to fucking die.
Okay, so
Hey,
today
my
we're looking
bitch.
at question 496, next greater element 1. The next greater element of some element x is an array. In an array is the first greater element to the right of x in the same array. You are given
Okay. We get it.
problem solving, I think. Nums 1, 4, 1, 2, nums 2, 1, 3,
This is like
4,
a bad way
2.
to like teach.
Okay, so given
Unironically.
these arrays, what we want to do is basically we see element 4, we look at the element 4 in nums 2, and we see if there is any larger elements to the right of this to this number. So 4 to the right, there's no more numbers bigger than 4, so we put in our result array minus 1. Next we look at number 1. We see that for number 1, the there is one element, I mean there's two elements greater than it, but the immediate right element that's greater than 1 is 3, so we put there 3. And lastly, for number 2, we can see that there's no more elements to the right of 2, so we again do minus 1. In the end, we return the array minus 1, 3, and minus 1. Let's check our answer. Okay, looks correct. So how can we solve this? We are going to construct a dictionary where we traverse through nums 2 once to figure out what is the pairings between for each of the numbers in nums 2. So we construct something like this dictionary, construct something like 1. The rightmost one is 3, and then 3, the rightmost one is 4. 4, there isn't any, so we can either put it into the dictionary or just not even bother with it. So let's not bother with it. And 2, there's no more rightmost element, so we end off with this temporary dictionary. And then taking this dictionary, we can traverse through nums 1 array, and then we check, oh, 4, there isn't a key in this dictionary, right? So we put minus 1 there. 1 has like a the key 1 has the value 3, so we put there.
I need to learn dictionaries. Oh my god, I don't understand dictionaries. The most alpha code, nigga. Shut up. I'm the alpha here. Okay. I sound like Akash Singh sometimes. Insecure, fragile. I'm not small though. I'm like 5'10". So yeah, 5'10".
A very, very important question for all of your interviews. This question has been asked by almost every big company like Microsoft, Facebook, Amazon, Google. So make sure that you are understanding the concept behind this.
That's the crazy thing. Like this neat code guy didn't even have it in its like top 200 or some shit. You know what I mean? So you just have to like go out your way and like in learning all of this shit.
I am talking about the problem next greater element 1 on LeetCode. I call this problem important because this problem can be transformed into many different ways, but the underlying idea will still remain the same. So let's see how we can go about doing that. Hello friends, welcome back to my channel, a place where we explore the life of, and we will look at some sample drift. It's not a feasible one. Going forward, we will try to optimize this solution and then also do a dry run of the code so that you understand how all of this actually works in action. Without further ado, let's get started.
It's monotonic.
Let us first try to make sure that we are understanding the problem statement correctly. I know that this problem is very verbose, so I have simplified it very much for you.
Yeah, bro, we get it.
Right? Look at this array.
Shut up.
Find any
Oh
next
my
greater
god.
element. So a sample array. This time I'm taking a very big array and we will try to find out the next greater element for all of these elements. So I have this output array with me, and in this array I will find out the next greater element for all of these corresponding elements. So how do you begin looking for the next greater element? The rule of thumb is you need to start looking from the left direction. So you have to assume that I'm looking from this direction and I have to find out the next greater element for each of these elements. Let us start from the beginning. I have element number 4 with me, correct? So when I start looking from the left direction, what is the first element that I find that is greater than 4? That will be 12, correct? So the next greater element for element number 4 will be simply 12. This is how you populate your array. Going ahead, I have the element number 12, right?
Minus
When you
1.
have to look for the next greater element, you don't start from the very beginning. You will start from 12 and then look all the way to the right. When you look all the way to the right, you do not find any element that is greater than 12, right? So for element 12, the next greater element will be minus 1. That simply means that you are unable to find the element greater than 12. Moving on to our next element, that is 5. So to find the next greater element, start looking to the right of 5. smaller, 2 is smaller, 5 is
Oh,
equal,
we
so you will
get
go ahead.
it, we
3 is small,
get it.
1 is small, 2 is small, 4 is small, and then ultimately you get 6. 6 is greater than 5, right? So for element number 5, the next greater element will be straight away 6. And you can write this in your output array. Similarly, for element number 3, the next greater element will be this 5, correct? So you are going to write down 5 over here, right? This is how you can go on filling this entire array, right? Try to do it as an exercise on your own. So now you know that the most naive way to approach this problem would be you start from the first element and then explore the entire array until you find the next greater element. So you start with 4 and start exploring the array. You find 12, so you will simply write down 12 as your output, correct? Next, you start with 12 and then again explore the entire array. You do not find, so enter a -1. Next, you start with 5 and then once again explore the entire array to find 6. And then you can write down 6 in your answer, correct? So this way you can populate your entire array. And this method works. You will find out a solution. But the problem is that you have to iterate through this entire array again and again to find the next greater element, correct? And hence, this solution is not optimized. If you submit a brute force solution on LeetCode, it will get accepted because this problem is under the easy category, right? But if your array is very large, if you have a lot of elements, then this approach will be very time consuming. So let us see how we can optimize this solution. Whenever you try to find an optimal solution, try to find out what was the problem with the brute force approach, and then try to work upon them. So let us say I have the sample array in front of me, and this is the array that I have to populate.
Bro, this is not even the fucking question, you doofus.
To find out all the next greater elements, correct? When we were doing a brute force approach, what did we do? We were traversing the entire array again and again, right? From the starting and going all the way up to the end, correct? Because it could be a chance that we are finding the next greater element towards the end of the array. For every element, we start from the beginning and go up to the end. We start from the beginning and go up to the end, right? So first of all, why not we start from the end itself? Because when we're starting from the end, then we have already covered all of these elements, right? So okay, you will start from the end. But there is one more problem that you have to solve about. When you're finding the next greater element, you have to give me the first occurrence of the greater element that you find, correct? For example, if you have the element 2, you have to return me 5 as your answer. Although 3, 4, and 6 are also greater than 2, right? But you have to return me the most recent element that you find, correct? That tells you that the most recent element, right? The most recent element means last in, first out. And that tells you that you have to take the help of a stack data structure. So let us say I have this helper stack for me, correct? You will ultimately get the intuition behind it. So how do we start solving now? Let us start with the last element, and that is 6.
Sometimes I just like realize I just have to like look in the code. Okay. Not this one. This. Yeah, he doesn't have the solution. Okay, let's just look at the solution, please. So this is the solution. Let's just copy paste. Copy paste it to just observe what's going on. Yeah, we just like forget that's like a possibility sometimes. So this is what's going on. Next greater, we're gonna assign a dictionary. Oh my god, I don't know what a dictionary is and how do I use it? How do I use it? How do I use the dictionary, bro? I don't know how to use the dictionary, bro. Using SF for num in reversed. Okay, we're just reversing that shit for some reason. While stack and stack minus 1 is bigger than num. Okay. How can it ever be bigger than the... Okay, the middle value, I think. It's referring to the middle value. Okay. What is minus 1? Okay, stack dot pop. While, okay, let's keep popping for every iteration. Bro, I don't understand this code at all.
Right now, our stack is empty. So what I'm going to simply do is, I will add 6 to my stack, right?
Mm-hmm.
And you don't have any greater element than 6, right? So
Yeah.
I can simply write down -1 in my output result, correct? Now move ahead. The next element is 4. Compare this element to the top of the stack. This element is smaller than the top element of the stack, right? That means this 6 is the next greatest element. So what I'm going to do is, I will write down 6 in my output result, and I will add this element 4 to my stack. Let us move on and you will slowly understand it. So the next element is 2.
6.
Once again, compare it with the top element of the stack. Since 2 is smaller, I will write down 4 in my output, and I will add 2 to my stack. Move ahead. I have the element 1. Compare 1 with the top of the
Bro, that's not even true. That's literally not even true.
stack. The top of the stack is 2.
Okay,
Once again, 2
next greater element. Okay.
is larger. So I will add 2 in my result, and then I will add 1 to my stack. So what you see over here, you see an increasing stack, right? That is the core idea. You will get your next greater elements in this stack. Let us see how you're getting them. So the next element is 3. This is where things will get interesting. Compare 3 to the top of the stack. The top of the stack is smaller than 3, right? So what you're going to do is, you will pop out the top element of the stack, and then once again compare 3 with the top of the stack. You see a 2 over here. Since 2 is also small, pop it out. Once again compare 3 with the top of the stack. Now 3 is smaller than 4. That means the next greater element for 3 will be 4. And then you can write down 4 in your output, and this 3 could be a potential candidate for your next greater element. So simply write down 3 in your stack now. So you see how the stack is always maintaining an increasing order of all the elements, correct? Moving on, I have the element 5. Once again compare 5 with 3. 3 is smaller, so I will remove this element. Now compare 5 with 4. Once again 4 is smaller, so I will remove it. Now compare 5 with 6. 6 is larger. So I got my next greater element, and that is 6. And what I will do is, I will simply add 5 to my stack. So this is how this process will continue on, correct? You might be wondering what will happen when I get the element 12, right? if at the element 12, this stack will become completely empty, right? Because there is no element greater than 12. So as soon as the stack becomes empty, you write down -1 in your answer, and you will add this new element to your stack. So your stack will always have the greatest element to the bottom, right? So this way you can approach this problem and fill up all of these elements. Try to complete them as an exercise. If this entire concept is clear to you, writing the code for this is very, very easy. Let us see how we can do that. For the code, I will just focus on finding the next greater element array. If you want the complete code and its test cases, you can find the link in the description below to my GitHub profile. So for this case, first of all, what I do is I create my next greater element array that will store all of my next greater element.
Bro, what even is this code? Nigga, what is this code? Is this JavaScript? Yeah, it is JavaScript.
Right? I also have a helper stack with me in which I will be storing all of the greater elements. So what I do is I start a for loop that starts from the very end and goes all the way up to the first element, right? And then what is the first thing that we did? If the stack is empty, that means we don't have any greater element, right? So what we're going to do is we will simply add 2 to our stack and add -1 in our next greater element array. So you see, we push the element to our stack, and in the next greater elements we add the -1.
Let's
And
actually
we're also going to pop this from the stack. And we're not going to stop there. We're not just going to check one value from the stack. This 3 could be greater than multiple values on the stack. So what we're going to do again is compare it to 2. Is 3 greater than 2? Yes, it is. So we're going to pop the 2. We know that 2 shows up at this index, so we're going to add a 3 at that index. We found the next greater element of 2. And now the stack is empty, so we can't keep popping values anymore. So we're done with that phase of the algorithm. Now is it time for us to add 3 to the stack? No, because 3 does not show up in the first array. So we don't need to find the... So m plus n. The space complexity is also going to be big O of m, 1 because of our hash. Initially is going to be empty, just like the...
Is he reversing the string? Bro, you're not even reversing the string. You're doing it wrong. What the fuck are you doing? What the fuck are you doing, bro? You're not even reversing the string, man.
Oh, very, very important.
Stupid ass motherfucker. Stupid ass motherfucker, man. Nate Diaz in this building, you know what I'm saying? Okay.
大家好，
I should stop talking like a retard.
小明，我们今天来看这个 LeetCode 的第496题 ，Next Greater Element 1。那么这道题的意思是说，对于 nums 1中的每个数，找到它在 nums 2中。
So we have results, and we have the stack for n in nums. Okay, reverse. We're taking the reverse, while s and m, while the s and n. What is n? So let's say we have 12 in the bottom and 5, and while 12 and 5 is less than or equal to s minus 1. Why does it have to be 2s? It could just be n. Oh, s would be the first one, the first top. Okay, while s
对应的这个数的后边，
so result is equal to result n is equal to s minus 1 if else I think I kind of get it. So let's actually code. Let's actually code. Coding, yeah, coding. Hello, fellow kids. And this feels like the proper thing to do. Like, go back. Okay, nums. While that is not true, yeah, this feels like the proper thing to do. I don't know why they're gaslighting me like that, with all of these like stupid ass ways to do things. Let's move on to the next thing though. What was that? Monotonic. Monotonic.
Hey guys, in this video.
Okay, let's do this one. 738. Sunshine and rainbows out here. 738. We are Charlie Cook. We carry the flame. No. Okay, let's do
Video,
this.
let's solve daily temperatures, leak code number 739. It's actually one of my favorite questions and one of the most eye-opening in terms
Bro, it's medium.
of getting better at solving these problems. So we're given an array of integers temperatures, and that represents the daily temperatures. And we need to return an array called answer, such that answer at I is the number of days you have to wait after the ith day to get a warmer temperature. Sounds kind of painful in writing, but with an example, it's pretty easy. If there is no future day which this is possible, keep the answer at I equals 0 instead. Okay, so the first example is really all you need here. We have the temperatures 73, 74, 75. It goes lower to 71, 69, 72, 76, 73. So at this position here, it's implying that we have to wait 1 day until we get a warmer temperature. Well, that's true. At 73 here, we immediately at the
We are Charlie Co. We carry the flame. We carry the flame. Okay, I'll do a stack, empty stack shit, and append and pop. So for maybe not for S. Um, while S is bigger, now if S is bigger than stack minus 1, if it is bigger, I should stack dot pop everything. I need to pop everything, right? I need to pop, if my shit is bigger than stack, no, you need to pop stack, else you need to append, you need to stack dot append S, and after you need to append it. Also, you need to result nah, that's not a right submission. Let's look at the solutions. Stack you don't even have to specify this. Why do you have to specify this? Oh, it's just like zeros everywhere because of the temperature. Okay. I was thinking doing a results for sure. It was a 0. It's gonna be 0, 0, 0, 0. How much of the temperatures are, and I'm gonna change the exact. Bro, I was thinking this. Oh no, I wasn't thinking that. Let's be honest. And we got the DP solution. Fuck no.
the next temperature, we get 74. And so we only had to wait 1 day. Same thing for this position.
Is this actually a medium question, or let's look at the.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve a problem, daily temperatures. We're just given an array of integers which represent temperatures, and we want to return an array answer such that at every single position in answer it's going to be the same exact size as our temperatures array, and at every single position in answer we want to know for the ith day, whatever the temperature was on the ith day, we want to find how many days did it take for us to find a temperature that was greater than the temperature on the ith day. So for example, let's take a look at this temperatures array. We can see there's 8 values in the temperatures array, and there's 8 values in the output for each value in the temperatures array. For example, 73. How many days did it take us in this array to the right of 73? How many days did it
it take us to find a new temperature that was greater than 73? Well, on the exact next day, we found 74, which is greater than 73, so it took us 1 day. So in the first position, we're going to return a 1. What about 74? How many days did it take us to find a new temperature that was greater than it? 75, 1 day later, right? Okay, for 75, how many days did it take us? 71 is not greater, 69 is not greater, 72 is not greater, but 76 is greater, and you can see that took about 4 days, right? So then we return a 4 in that position. Now there are some temperatures that never had a temperature greater than them. Look at these last two temperatures. We had a 76, nothing to the right of 76 is greater than it, and of course the last position, 73, there's no temperatures to the right of it in the first place, so nothing was greater than 73 to the right. So for these ones, we're going to return a default value of 0. So we're going to build an output array. Now looking at the input, what's the
I think length of stack is the thing.
force way to do it. Of course, we could do an n squared approach, right? Like for every temperature, we would look through the entire temperature array after it, right? And see, okay, how many days did it take us to find a temperature that was greater than this one, right? And then do the same thing for the next temperature over here. Look through the entire array, see, what's the first day that we can find a greater temperature, and keep doing that. Now that's going to be big O of n squared time complexity, but there actually is an easier way to do this problem if we use some extra memory. Now let's just iterate through the input array once going to the right. But we do
Log
need to know
of n,
that, for
that's not even 2n squared. That's log of n.
example, we have to remember the previous
N log n
temperatures that we looked at. So if we, let's say the previous temperature here was a 73, like in the...
Let's actually look into it. I'm so like smart. I'm so smart and charismatic.
For example, and then the next temperature was a 74. When we get to this position, we have to somehow remember what was the temperature that came before it, right? Now, obviously, we could use a list for that, or in this case, a stack would be more intuitive, because one thing we're going to notice is if we get a temperature greater than it, 74, right? Then we're going to say, okay, what was our previous temperature, 73? So this temperature is greater than it, right? So we can keep track of what index this occurred at and what index we're at right now, and say, okay, the difference between these indexes was 1, right? We clearly found a temperature, the first temperature greater than the 73. So then what are we going to do from our stack? Well, then we don't have to remember this anymore, right? We're going to say, okay, we're going to put a 1 in the output, and we can pop this from our stack, right? So we're going to do stack.pop. So this will be popped from the stack. Now when we get to a 75, the exact same thing is going to happen, right? Clearly we see these temperatures are in increasing order. So we see, okay, 1 day it took us to get a temperature greater than this. We'll put a 1 in the output, pop this from the stack. And if we just had increasing temperatures, that would be really easy for us, right? But it's not always going to happen where we have increasing temperatures. What happens if we had a 72 that came after it? Well, we would look at the 72 and compare it to the top of the stack, say, okay, this is not greater. So we can't pop from the stack, but we're also going to take this value and add it to the stack. So now we're going to have 2 values inside of our stack. And what happens if we got another smaller value, 71, right? So far for none of these values do they have a temperature to the right of them that's greater, right? So all 3 of these are going to be on the stack. What are we noticing about our stack? It's going to be in monotonic decreasing order, right? This is a type of stack problem that I've solved on this channel a couple times, but this is more of a beginner-friendly monotonic decreasing stack problem. What this means is that our stack is going to be in decreasing order. That's what monotonic means. It's always in decreasing order. Now, technically, what happens if we got another 71 over here, right? Well, in that case, 71 is not greater than this, so all 4 of these would be on our stack currently, right? So it's technically not monotonic decreasing order. It could be equal as well, right? We're noticing it's not strictly decreasing. If 2 values are equal, they're also going to go on the stack. But if we got a greater value, if I got to a 72, right? What am I going to do? Clearly, 72 is greater than the top of our stack, so I pop this one, right? But now we have a new value on the top of our stack. This one is our 72 greater than this? It's not. So our stack is like this now. We looked at our stack. We took this guy out. This is no longer in our stack, but these 3 values are in our stack. And still, notice how the stack is still in monotonic decreasing order. It's always going to be the case. What happens if instead of a 72, I had a 73? Then, of course, we'd still pop the 71, and then we'd also want to pop the 72 because now 73 is greater than 72. We pop this, but it's not the case for this one. But if we change this value to a 74, excuse my bad handwriting over here, but if we change this to a 74, then yes, we are going to pop this one as well. So no matter what we do, our stack is always going to be in monotonic decreasing order. If I add a 70 over here, we're not going to pop anything. It's still in decreasing order. So let's just run through a quick simulation. Let me show you how we can get this output in linear time using a stack. So first value 73, we're going to compare it to the top of our stack. Our stack is empty, so we're not going to do anything. We're just going to take the 73, add it to the stack. Next, we're at 74. We're going to compare it to the top of the stack. 74 is greater than 73, right? What index did 73 occur at index 0? What index does 74 occur at index 1? So we take the difference, 1 minus 0. So it took us 1 position to find a value greater than 73. So we can pop 73 from our stack, and then 74 is going to be on the top of our stack now. Now, exact same thing's going to happen with 75, right? 75 is greater than this. The difference between the indexes is 1. So we add a 1 to the output for 74, and we pop 74. Now and we add 75 to the stack. Next, we get 71. 71 is not greater than the top of our stack, so all we do is add it. We don't update the output in either of those positions. Again, we get a smaller value, 69. So we add it to the stack. We can't pop any of these. 69 is not greater than either of these. Next, we get a 72, right? 72 is greater than 69, right? So we pop 69. What was the difference between the indices? It was 1. So we're going to take in the corresponding output position, which is in this position for 69, we're going to say, okay, there was an index difference of 1. Now we're going to look at the next top of our stack, 71. So the difference between these two is 2. So for 71, we're going to say it took 2 days for us to find a greater temperature than 71. So for this position, we had a 2. So we pop 71 from our stack. Now 72 is not greater than 75. So we still have a hole in our output over here. We never found a greater temperature than 75. If we can't, we're going to have a result or answer, but we're also going to add a temperature and the index that temperature occurred at.
Hallelujah, hallelujah, hallelujah. No yapping. I wanna no yapping, clean cut.
Hello and welcome. Today we're doing a question from LeetCode called Daily Temperatures. This is part of LeetCode 75. If you are following along, I have that playlist linked down below, as well as all the other playlists we've done. They're all linked in the description. So what is this question? We're given an array of integers called temperatures, which represents...
I don't know if bro, I haven't wrote a single line of code. I kind of get this for... I kind of get that, but enumerate, I don't get it. Like, what's with that? Fuck sake. Temp. I kind of get that, but enumerate, no fucking clue, bro. Temperature, okay. Stack, I don't get the stack thing. Like stack and stack, what does it mean? Enumerate. Let's go here. Stack. Cut this shit and go stack. Maybe not. Stack and T. Let's go here. Stack -1, I think. Maybe, I don't know.
On the top of our stack, the top of our stack is index -1 in Python, and the temperature is the first value in that pair, so index 0. And so if this is true, of course we can pop.
Bro, I don't get this. What is going on? Where is -1? And 0 for some reason.
From our stack, right? So stack.pop. So I'm going to call it the stack temperature and the stack index, which we just popped, right? And for this temperature, we want to, in the result, I'll say, okay, whatever the index of this temperature was, stack index, we want to compute the number of days it took us to find a greater temperature. We can do that with I.
Bro, you're losing the plot, bro. You're actually losing the plot with this one. Bro thinks the world is sunshine and rainbows. Monotonic. Monotonic stack. Teach me more about that, Lord. Netanyahu, teach me more about that, if you can hear me. Basic stack, remove all adjacent. Okay, let me the monotonic shit is kind of like throwing me off. I think I need to do some basic shit before. Let's go here. Let's go, champ. I need to go here. Bro, why is it so cold? Oh my god. You're given a string consists of lowercase English letters, and a duplicate removal consists of choosing two adjacent equal letters and removing item. We can repeatedly make duplicate removals of S until there's no longer... Okay, what the fuck? I don't know, bro. Let's just repeatedly duplicate removals of S. So abracadabra, you can review BB AA. Okay, I know how to do this. So we're adding every single thing to the stack, and whenever they coincide or get like, it's basically like Candy Crush. So we're going stack, we're going stack because we're black like that. And for I and S, okay, string, we're gonna like iterate over every single thing while, okay, if we see I, should I use enumerate? I could do enumerate, I think. What is enumerate even? God only knows. If I see N, if N is in stack, no. If it is in stack, I should add it. If it is not in stack, stock dot append. Okay, why am I? Okay, who cares? Append N. If it is in, okay, if it is in, and I need to pop both of them. I don't have to do anything. I could just like pass. Else, I can do okay. If N, if it is in N, I mean if A is in the stack, which you wouldn't. Okay, if it's not in the stack, if N is not in the stack, we're gonna append. Okay, we're gonna stack dot append that into the stack. If it is already in it, we're gonna pop stack dot pop N, both of them, and we're gonna do that. And after that, if stack is true, if the stack is still on, I don't know how to like find it. How do you do it? If return true, if stack, if not stack, else false. This is the shit. So I need to return true. No, I need to return not true. I need to return the stack. No, I need to return S. If not stack, if nothing is in stack, if not stack, else false. Okay, what the fuck does that mean? No, that's a bad logic. Let's look at the solutions. Okay, let's look at the, I don't know how to do this. I'm stuck. Let's go here. Let's go here. Let's go here. Remove all duplicates, part 2. Nigga, where's the part 1? Fucking retard.
Hello, and welcome back to the Cracking Fang YouTube channel. Today we're going to be solving LeetCode.
Give me a second, bro. I need to get connected with you. Fuck's sake.
Problem 1047. Remove all adjacent duplicates in a string. Let's read the question prompt. You are given a string S consisting of lowercase English letters. A duplicate removal consists of choosing 2 adjacent and equal letters and removing them. We repeatedly make duplicate removals on S until we no longer can. Return the final string after such duplicate removals have been made.
top of the stack, which is this A. Okay, we're now in the editor to our stack. We're in the stack, then it doesn't matter. We can just append our current character. We wouldn't be able to pop even if we wanted to, because the stack is empty, and if you try to pop from an empty stack, your code's gonna blow up. So we're gonna say if not
we don't want
stack,
that.
then we can simply append the current character to the stack. So we're gonna say stack dot append the current character.
If not stack, what does that even mean? If not in stack, what is not in stack? If S not in stack, if I not in stack.
Simply check whether or not our current character equals to the last character that we added to our stack, which is serving as a string builder. So let's define that variable. So we're going to say stack is going to from left, if we be able to pop even if we're going to stack the append the current character. Otherwise, we now need to verify that our current character char does not equal to whatever is at the top of the stack. If it's not, then we can append it to the stack. If it is, then that means that we're going to have two characters that are next to each other, which we're not, and which we can't do. Otherwise, if it's not the same, then we can simply append the characters to the stack. So we're going to, all we need is solution form, and dot join stack, which will return our answer in actually string format. So let's
dot join stack.
Submit this and double check that it works. And
that is sketchy as hell. Let's try this. I think it's still gonna work. If stack is equal to if both are equal to each other. No, it's -1. Why does it have to be -1? It can be anything. It should be okay. Oh yeah, like we want that kind of effect, don't we? We want that Candy Crush effect. If that's true, we're gonna pop S of n. We're gonna stack dot pop S of n. Okay, that's clean. Else we're gonna stack dot append we're gonna append. What are we gonna append? We're gonna append S. No, we're gonna append n. We're gonna return this thing, join n. Is that what it is? Join stack, because we're gonna the thing with stack is we got nothing though. We got nothing in stack. Oh, makes sense. Okay, makes sense. Definitely makes sense. Yeah, just pop n, bro. Just pop the n. Oh, not even pop the n. Just pop. Just pop. Why didn't it pop? If it's not... So what is happening? I think it's coming to this particular thing and it's like popping it in. I think it should be a while loop. Bro, this is... I have a feeling that this exact question is going to get asked to me. Okay. Is that the solution? The funny thing is, bro, these motherfuckers just copy the code and paste it, and they pretend they like fucking invented it. That's what they do. Telling you, bro, that's exactly what they do. They like change up the fucking variable names, like pretending like we don't like we don't see it. Like, we see you, bro. We see you. So what's going on here? Yes, so far it should work for sure. I don't understand this though. The last one. What is the... Let's get this one. Go here. So we have a stack, an empty stack for I and S, okay? If stack and I is equal to... Why is it and? Okay, it's a three-way chain. If this, this, and this, okay. Stack is going to be nothing. It's going to be, okay, we need to append. Bro, that's actually fucking smart. So when... That's my fucking pen. I'm rhyming like I'm Carlson. Like Ken. Okay, so we have A, B, B, A, C, C. A, okay, this one. So when A gets on the stack, when there's like nothing on the stack, it goes, okay, there's nothing. Let's just append A. And when the A is on the stack, okay, A is not equal to the minus stack. Okay, let's append B. When B comes up, it's going like, okay, stack. Okay, B is equal to the last one. So we need to pop B. That's fucking smart. That's fucking smart. Print stack. So we have A. What the fuck? Nah, just stack before, bro. So you have nothing, and we got A. Of course, stack has nothing in it. So what happens when it's AZ? What happens this time? AZX, AZX, AZX. So at the AB and B is equal to stack minus 1. It is not though. E. Let's go. It shouldn't, but it does for some reason. Ow. Bro, niggas be. Yo, too much smoky coming out of Canada. Stack. Okay, your code. Okay, we get it. Where the part. Okay, the stack is not empty, and okay, it's just like okay. This is we're not. We're gonna go done. Okay, similar question to this one. What? Exceeded output? Nigga.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem implement a stack using queues. I think this is a really good problem for beginners to first value out. So basically if we add
Okay, I'm just gonna take a break. Should I multitask? I think multitasking is like really good. When how do I like fuck? I think I should start streaming on my other laptop. Because I wanna like listen to some shit, but I can't. Listening while you're doing it sounds like a suicide, bro. Yeah, I need to end the stream right there.